first half of Chapter 11 was about how to calculate the surface area of three-dimensional shapes. The second half is about calculating the volume instead. Quick reminder about volume. When we're measuring volume, we're using cubic units. Quick overview of why. When we're measuring length, that's a one-dimensional shape, so it's units to the power of 1, or just units. But when we're talking about area or surface area, that's a two-dimensional shape, so it would be units squared. But for volume, we're measuring how many cubes fill the inside three-dimensional space of your shape, so that's units cubed, because it's three-dimensional. Now, when you're calculating the volume of the prism, you want to first find the area of the base, and then multiply by the height of the prism. So for problems like question 1, you'd find the area of the base, 12 times 5, since it's a rectangle, just base times height, and you'd get 60. To find the volume, you just take the area of the base and you multiply by the height of the prism. The logic of this area of base times height formula is this. If you find the area of the base, it's 60, and you stack it on top of itself to fill up the inside of the shape, that would be stacking on top of itself 6 times for this example, you would really just take the area of the base and multiply by the height to stack it to fill the space. Pause the video here and try question 2 on your own. It's really important to remember that with prisms, the sides you look at as the bases have to be parallel and congruent. So in this case, the rectangular base would not quite work because there's no parallel congruent rectangle on top. The bases you'd have to use would be the two triangle sides. Area of a triangle is 1/2 base times height, so your base area would be 60. Take that and multiply by the height. You could think of it, the height is really just the distance between the two bases, or how tall it would be if you flipped your prism so that the bases were on the top and bottom sides. So 60 times 22 would be 1,320 cubic inches. You could actually derive the formula for volume of a cylinder by starting with your formula for volume of a prism. For prisms, the volume is area of base times height, and a cylinder is a lot like a prism except it has circular bases. So if you know the area of the base is pi r squared, you plug that in for capital B, and your official formula for volume of a cylinder is pi r squared times height. Go ahead and try the next 2 problems on your own. Pause the video until you're done. Go ahead and check your answers for questions 3 and 4. You plugged in the radius, the height, and then you just simplified. Remember, order of operations, you have to take care of the exponents before you multiply, so make sure you did 3 squared before multiplying by the 5 for number 3. Don't forget your units are cubed. Pause the video here and try question 4 on your own. For question 5, it's first a good idea to summarize the information the word problem gives you on the picture. They tell you that the hole has a diameter of 14 centimeters, and that the whole cylinder has a diameter of 20 centimeters, and that the height is 5 centimeters. So if they want to know how much volume or how much space the cylinder with the cutout would have left, you would first find the volume of the whole original cylinder, then you'd find the volume of the hole that's cut out, and then you would subtract it. Notice how, because they're telling you diameter, you have to be careful to figure out the radius before you plug that in. So the radius of the hole would actually be 10, not 20. The radius of what you cut out would be 7. So plug that in and then subtract the 2 volumes to cut out the smaller cylinder and see how much volume is left. Cavalari's principle. Copy this down. This part is fascinating. Cavalari's principle says that if you have two three-dimensional shapes that have the same height, and the same cross-sectional area at every level, then those two shapes have the exact same volume. So these two prisms here, because they have the same height and the same cross-sectional area here and here, and it's the same size squares for every cross-section you could cut out of your shape, they would have the exact same volume, even though this one is leaning. Here's the logic behind this. If I had a stack of books that's leaning, that's slanted, it's not going to have any more volume or any less volume than it would have if I straightened out the stack of books. It's the same number of books each way. It's taking the same amount of three-dimensional shape. This applies not only to prisms, but to other three-dimensional shapes like cylinders. If I have a leaning cylinder, like a stack of CDs, I could straighten out my stack of CDs and calculate the volume of that cylinder to figure out how much space it had when it was leaning. So go ahead and see if you could solve questions 6 and 7 on your own. Pause the video until you're done. Because you know that the volume of this prism for number 6 would be the same if you just straightened it out. You just straightened out your stack of books mentally. You just find the area of the base and multiply by the height. Same as usual. Same with the cylinder here. You plug in the radius, which is 1 since the whole diameter is 2, and you multiply by the height. Well done. Pause the video here and try the last question on your own. Oh, and go ahead and fill in the definition of composite space figures. Composite is really just a fancy word for combination. You'll see it in both math and science classes. So a composite space figure is a three-dimensional figure that is a combination of two or more simpler figures. So here, you have a half cylinder and a prism combined. To find the volume of the whole shape, you just find the volume of each piece and add it up. For the half cylinder, because the base of the prism is 9, you know that the cylinder has that diameter of 9. Half 9 and the radius would be 4.5. If this side of the prism is 11, that's telling you the height of your cylinder as well. So you take the radius and the height, and you plug it into your volume formula. You just have to remember, because it's half a cylinder, you have to divide by 2 at the end. Then you could find the volume of your prism. The area of the base is 9 times 11. Multiply that answer by the height of 6. And then add up your pieces to get the full volume.